In this video, we'll look at some more examples of problems where L'Hopital's rule applied that are a little bit more complicated. So in this first one, we have the limit as x goes to infinity of x over natural log x. So if we think about this limit in the numerator, as x goes to infinity, x is, well, going to infinity. And then in the denominator, as x goes to infinity, natural log of x is also growing without bound, so it also goes to infinity. So we see that this limit has the indeterminate form infinity over infinity. We can't conclude anything from that, but this is a case where we can use L'Hopital's rule. So this limit is the same as the limit of the derivative of the numerator divided by the derivative of the denominator. So in the numerator we have x, derivative of that is 1. In the denominator we have log x, the derivative is 1 over x. And if we simplify a little bit, we see that this is just x. And so once again, as x goes to infinity, x, well, goes to infinity. So our answer is going to be positive infinity. Okay, in the second problem, if we think about the limit as x goes to infinity of the numerator, we get e to the x, which is growing without bound, and x, which is growing without bound. So this whole numerator is going towards infinity. And the same for the denominator. Both of these parts are growing, and so that is also going to infinity. Now, it's important that we check every single time that the different pieces are going to infinity so that we actually know that we have this indeterminate form infinity over infinity, or sometimes 0 over 0. Only then can we apply L'Hopital's rule. Okay, so again, I'm going to take the derivative of the numerator and of the denominator separately. And it's actually also a good idea to go ahead and indicate here that that's what you're doing at this point. So up here, I'll also write LH, just to tell whoever's reading this that this is equal because of L'Hopital's rule. Okay, so I'll take the derivative of the numerator. I get e to the x plus 1. I'll take the derivative of the denominator. I get 2e to the x plus 2x. And what happens now? Well, again, I see that the numerator is going to infinity, the denominator is going to infinity. So again, I get infinity over infinity, which means I can use L'Hopital's rule again. So once again, I have the limit as x goes to infinity. Now in the numerator, I'll get e to the x. In the denominator, I'll get 2e to the x plus 2. At this point, I can use L'Hopital's rule again, because again, I have infinity over infinity. There is an alternative, which I will show you in just a minute, that you might like better. But again, because this is infinity over infinity, let's do it one more time. You know, it really seems like we're having to do this a lot, but at least taking the derivatives of exponentials is not so bad, because now in the numerator we just have e to the x, right? The derivative of e to the x is e to the x. Now in the denominator I have 2e to the x, and I can see those other terms have just sort of disappeared. And now I don't have to use L'Hopital's rule because I can cancel these e to the x terms, and I get 1/2. And that will actually be my final answer. Now, an alternative, once we get to this point here, would be to divide the numerator and the denominator by e to the x. And if we did that instead, what we'd get is we'd get 1 in the numerator, and we'd get 2 plus 2 over e to the x in the denominator. And then as x goes to infinity, this term, 2 over e to the x, will go to 0. And so again, from here, we could see that the answer when we take the limit will be 1/2. We'll get the same answer either way. Okay, so for this next problem, natural log of x over 1 over x, as x goes to 0 from the right side, Well, natural log of x as x goes to 0 from the right is going to be negative infinity. It has that vertical asymptote there. And then 1 over x as x approaches 0 from the right will be a positive infinity. And so L'Hopital's rule still applies here. Even though it's negative infinity over infinity, it still has that infinity over infinity indeterminate form. So I apply L'Hopital's rule, and in the numerator, I get 1 over x. In the denominator, the derivative of 1 over x, or x to the negative 1, is negative 1 over x squared. And again, at this point, I want to simplify, right? So if I sort of flip that 1 over x squared upside down, I'll get negative x squared over x, which will simplify to negative x. And then I can see now that as x approaches 0 from the right, this is also approaching 0. And that will be my final answer. Okay, let's do a couple more. So for number 4, if I plug in pi over 2, tangent of pi over 2 is going to be, let's think that that's sine over cosine. And so that's going towards 1 over 0. So that's where tangent has like a vertical asymptote. And so it's approaching infinity. And then what's happening in the denominator? Well, in the denominator, that looks like it's approaching 0. So this kind of looks like it's approaching infinity over 0. And that is not an indeterminate form, right? Because what that's saying is that the numerator is getting really big and the denominator is getting really small. And so both of those things are leading to the overall value getting big. So we can't apply L'Hopital's rule. It doesn't have an indeterminate form of 0 over 0 or infinity over infinity. Basically, what this is saying is that this is going towards infinity. We just have to decide whether it's positive or negative infinity. So the top tan x, if we go to pi over 2 from the left, that's approaching infinity from the positive side. And as we approach pi over 2 from the left, the numerator, we're plugging in things slightly smaller. So that's approaching 0, but from the negative. So I would say overall, this limit is going to be going towards negative infinity, okay? Because we have a positive divided by a negative, and that's going to give us a negative answer. Okay, and then finally at the end here, what do we have? Well, we have something that looks like infinity times e to the negative infinity, which is going to be 0. Infinity times 0. This is an indeterminate form, but it's not one that we can apply L'Hopital's rule to right away. We need to change it. We need to make it look like infinity over infinity or 0 over 0. So there's different ways to do that. Here, I think the easiest way will be to take that x to the e to the negative x and put that in your denominator. Okay, so now this looks like infinity over infinity. So now we'll use L'Hopital's rule. And we get 1 in the numerator, we get e to the x in the denominator, and now we know that e to the x goes to infinity as x goes to infinity. So 1 over something that's getting very, very, very big will end up with 0.